Hi, everyone. Last week, I put together a couple of videos on multi-level path analysis using the lavaan package with RStudio. And what I wanted to do in this video is just to build on that discussion by showing you another model that you could theoretically test. So before I get started, I do want to mention that underneath the video description, you'll find a link to the data file that I'll be using in this video presentation. So feel free to download a copy of the data to follow along. You will also find a link that will take you to some additional information that you might find useful in the context of this discussion. And at that link, you'll also find the syntax that I'm using throughout this presentation. I also want to acknowledge the source of the data that we're using. It's coming from this article right here, linking colleagues support to employees promote a voice, a moderated mediation model by Shi et al. From 2015. This is located at the +ONE website. I was able to download the data from the supporting information link that the authors provided. So we are using the data from this article, but we're not actually testing the model that the authors proposed. So before we open up RStudio and begin running our analysis, let's just talk about the model and the data a bit. So basically what we have is employee level data where individuals are nested within work teams. So employees are the level 1 units, work teams are level 2 units. And so you can see that we have the basically the same model represented at levels 1 and 2. In a nutshell, we have psychological safety and team identification serving as predictors of promotive voice, and their effects are being mediated by felt obligation. So in our model at level 1, we have measured the measured variables: psychological safety, team identification, felt obligation, and promotive voice. And again, felt obligation is proposed as a mediator between psychological safety, team identification, and promotive voice. The level 2 variables that we have psychological safety and team identification, but these are measured at the team level. And these are essentially compositional variables created by computing the team level means of the level 1 variables: psychological safety and team identification. So we have the team level psychological safety, team level team identification, and those are serving as predictors of team level felt obligation and team level promotive voice. And the reason why felt obligation and promotive voice at level 2 appear as ovals is because we're essentially predicting variation between teams in these characteristics, and it's essentially quantified as in terms of the variation in the intercepts or the team level intercepts. So we're not directly measuring those variables at level 2, but rather we are predicting variation in team level intercepts for felt obligation and promotive voice. Okay, so here we are in RStudio, and I already have set up or set the working directory in relation to the data set that I have on my computer. So we'll quickly import the data. We'll go to File, Import Data Set from Text Base, and we're going to select PR Voice V5. This is a CSV file. I'm going to click Open. We want to make sure that the heading is set to yes, as it is right here. So we're going to click Import. And now the data is imported and we are ready to go. So we'll go ahead and click on File, go to New File, our script to open up the script editor. And just briefly, we read the data in from the CSV file. And so the data is actually stored in a data frame, which is named PR Voice V5. So the name of the data frame is the same as the name of our CSV file. So we'll take a quick look just at the structure of the data. We'll use the structure function and type in PR Voice V5. And we'll highlight that, click on Run. And you can see that we have our variables in our data set. In particular, we have our PR voice, promotive voice. We have SciSafe, psychological safety, and then we have there's felt obligation, and then we also have the team ID right there. All of those variables are measured at the individual level or the employee level. So at this point, we don't have the data. We don't have the team level versions of team ID and psychological safety. So we need to compute those compositional variables. So to do this, we're going to type in library, and we are going to use a function associated with the MIT-ML package. So if you don't have the MIT-ML package um, installed yet, you're going to need to do that before you can use library function to call it up. So I'm going to go ahead and call up the package, and it's ready to go. So it's been activated. So now what we're going to do is we're going to create our new variables, the compositional variables for level 2. So to do this, we're going to type, first off, we are going to type PR voice V5 $, and then team ID, and then _M. And we're going to make sure the ID and M are all in caps. So basically what this is doing is we're going to be adding a variable to our data frame. The data frame is this is PR voice V5. We're adding the variable team ID _M. To do this, we are going to use our assignment operator right here, and we're going to use the function cluster means from the MIT-ML package. We'll type PR voice V5 $, and then team ID. So that's the original variable at level 1. Then comma, we'll type cluster, and we'll set this equal to PR voice V5 $, team code. So team code is this variable right here, and this is the team level identifier variable. So just keep in mind that we are referencing right here the name of the data frame. We're referencing the variable within that data frame, team ID. The same goes right here where we're referencing the data frame and the variable that is associated with the team level, basically the team level identifier variable. So next we'll go to the next line here. We'll type in PR voice V5 $, and we'll type in SciSafe _M. And these are just, the team ID _M and SciSafe _M. There's nothing special about the naming. It's just my name that I'm giving these particular compositional variables. Next, we'll type in cluster means. Make sure that the M for cluster means is in caps. Then we'll type in PR voice V5 $, and then SciSafe, and then comma cluster equals, and it's the same thing that we had above, $ team code right there. So next we'll highlight both of these, click on run, and so now they should be stored in the data frame. So we'll use the names function to check it out. So we'll type PR voice V5. And you can see in the data frame that now we have team ID _M and SciSafe _M. Both of those have been saved to the data frame. So now we're ready to run our analysis. We're going to use the library function, and we're going to call up lavaan. So that's the first thing. Then the next thing we'll do is specify our model. So I need to create essentially an object that contains the model information, or rather the model specification. So I'm going to call it model 1A. We use our assignment operator, and we start with a single quotation mark right here. So just keep in mind that our model, after we specified it, we need to have a quotation mark at the prior to starting the specification and then following. So the next line, we're going to type in level : and then 1. And then we'll also go down, we'll type level : and then 2. And keep in mind that we don't specify level 1 : or level 2 : it has to be in this format in order for us to run our analysis. So then from there, we specify our model, our level 1 model, and then our level 2 model underneath the level 1 : level : 1 and level : 2. So for a level 1 model, we have PR voice, tilde, and then felt obligation. So the variables as they're given in the data frame, these are the actual names in the data frame. The tilde is basically indicating a regression. So we have the promoted voice regress onto felt obligation. And then we're going to go down to our next line and type in felt obligation, or OBL, tilde, and then safe or psychological safety plus team ID. So that's our, so at level 1, we're regressing felt obligation onto psychological safety and team identification. So then for level 2, we're going to specify PR voice, tilde, felt OBL for felt obligation. And then we're going to type in felt obligation, OBL. We're going to regress that onto our compositional variables. So we're going to type in safe underscore M plus team ID underscore M. So that's the basic specification for our model. We also need to make sure that we end our model specification by including the end quote. So just keep in mind that when you're using lavaan, that the model has to be specified between quotation marks. So we have the beginning quotation mark up here, and then we have the ending quotation mark down here. Okay, so then we'll go ahead and save this specification as model 1A. So I'm going to go ahead and click on run right here after highlighting it. So it's ready to go. So now all we need to do is to run our model. So I'm going to create a new object. I'm going to call it fit1. We have our assignment operator, and we're going to use the SEM function. And we'll type in model 1A. So that's our model that we specified above, comma, we'll set data equals to the name of our data frame, which is PR voice V5, then comma, and then we have to specify our cluster variable. So we'll type in cluster equals, and then team code. Make sure that that is inside quotation marks. So we'll also want to, when we run our analysis, is to generate our output. So we're going to use the summary function, type in fit1, and then some other things that you might want to ask for. You might request some additional fit measures by typing in fit.measures. We'll set this equal to T, or you could spell out true, but it has to be all in caps. And then R square, set this equal to T as well. So now we'll highlight both of these and click on run to generate our output. Okay, so looking at the chi-square goodness of fit test right here, you can see there's the chi-square test value, degrees of freedom for the model, and then the p-value. You can see it's not significant, which would be suggestive of a good fitting model. Then you've got the comparative fit index of 1, Tucker-Lewis of 1.032. Both of these are suggestive of a good, strong, basically strong model fit. Then you can look at the RMSEA at essentially 0, which is also indicating a good model fit as well. And then you also have the SRMR, standardized root mean square residual, at the within level, and then also at the between level. At the within level, it looks like we have a good fit. At the between level, not quite as strong of a fit. When we look at the level 1 regressions, you can see that we have felt obligation serving as a predictor of promoted voice. It's a positive and significant predictor. Then psychological safety is a positive and significant predictor of felt obligation. And team ID is also a positive and significant predictor of felt obligation. We'll scroll down a little bit further and look at the level 2 regressions. You can see that felt obligation, the effect of team level felt obligation on team level promoted voice, we have a positive regression slope, but it's not statistically significant at the conventional 0.05 level. Then we have negative slopes for team level psychological safety and team level team identification on felt obligation. Neither of those were statistically significant in the model. Now, one other thing that you might want to do when you're running your analysis is to carry out tests of or mediation tests, or testing indirect effects for the models. So what we can do is we can essentially modify our syntax so that we incorporate labels for the various paths and then specify estimands in order to compute the indirect effects and their associated significance tests. So before doing that in lavaan, what I thought I would do is just kind of briefly go over my labeling of the paths. So at level 1, I'm going to assign labels of L1A1 for the path from psychological safety to felt obligation, L1A2 for the path from team identification to felt obligation, and then L1B for the path from felt obligation to promote a voice. At level 2, we'll use L2A1 and L2A2 for the paths from psychological safety and team identification to felt obligation, and then L2B for the path from felt obligation to promote a voice. And the estimands that we'll be creating are IE1, and there'll be an IE2, and then that should be a 2 right here instead. And then basically IE1 is the product of this path right here and this path right here, and IE2 is going to be the product of this path, L1A2 and L1B. And then at level 2, IE3, the indirect effect is going to be computed as a product of the L2A1 path and L2B path, and IE4 is going to be computed as a product of L2A2 and L2B. So what we'll do is go ahead and modify the syntax for model 1A. For the level 1 model, we'll type in L1B and then an asterisk right here. And essentially that's assigning the label L1B to the path from felt obligation to promote a voice. Then for psychological safety, we're going to assign the label L1A1. So we'll do that by typing L1A1 asterisk SciSafe, and then L1A2 asterisk for team ID. For level 2, then we'll type in L2B asterisk for the path from team level felt obligation to team level promote a voice, and then L2A1 for the compositional variable, the path from SciSafe, the team level mean for psychological safety to felt obligation, and then L2A2 for team level identification to team level felt obligation. So we've assigned the labels now to our paths. So now what we need to do is to generate estimands. So to do this, we're going to create a name for our first estimand, the indirect effect of psychological safety on promote a voice by way of felt obligation. So that's going to be our IE1, and we're going to type in colon and then equal sign. So keep in mind that the IE1 is just a name for our estimand. There's nothing special about it. But we do have to type in the colon and the equal sign, and then the expression on the right-hand side of our equation here is going to specify which paths are being multiplied. So we're going to type in L1A1 asterisk and then L1B. So in this case, though, the asterisk is indicating multiplication. So we're multiplying the coefficient for this first path times the coefficient for the second path. Then we'll type in IE2 colon equals, and then L1A2 times L1B. Okay, so that's going to be in order to compute the indirect effect of team identification on promote a voice by way of felt obligation. At level 2, we're going to specify our next set of estimands, And so in this case, we're going to type in IE 3, then colon followed by equal sign, and we're going to type in L2A1 asterisk L2B, and then that's going to represent the team level psychological safety on team level promoted voice by way of team level felt obligation, and then IE4 colon equals, and then L2A2 asterisk L2B right there. So at this point, we've specified our model, added labels to the paths, and also included Estimand. So when we generate our output, we should get indirect effects included in our output along with the significance test for those indirect effects. So we need to highlight all of this yet again for our model because we need to update that object. So we've done that. And so then we just rerun our analysis as before. We'll click on run, and it looks like there was an error that was generated. It turned out that I had in the original text, or what I was typing in, I ended up typing in a 1 instead of an L up here, and so that affected the Estimand. So anyway, I've corrected that. So now we're all set. I'm just going to go ahead and highlight everything, click on run. And so now you can see that we get our output yet again, with all of the results are exactly the same as before, except that now at the very end of our output, we have defined parameters. We have the indirect effects that are given. So these are the estimates for the indirect effect, and you can see there's our p-values for those. So you can see that the indirect effect at level 1 of psychological safety and team identification on promoted voice, those indirect effects were statistically significant. The level 2 indirect effects, not so much. You can see that we have our negative coefficients for those indirect effects, but you can see neither of those were statistically significant. Okay, so that is pretty much going to round out this video presentation. Hopefully you found this useful, and I appreciate you watching.